Hello friends, welcome to our fourth session about the fourth method of discussing about the sensitive ground fault detection methods. We are on the fourth method and this is our fourth session. In the previous, in the first session we just had an overview about the block diagram functionality. On the second session we said that if our system be inductive, resistive during the fault, it means the arc suppression coil grounded system, we use G as a measuring method. And if our system be resistive, in the third session we discussed about if our system is resistive, resistance grounded, the ground fault current will be the zero sequence component of ground fault current will be inductive in nature. So on that time we use G0 and we tilt by minus 45 degree. Then in this session we are discussing about another system, that is a system which is not grounded and it's isolated system. In the isolated system we can have two options according to our system and according to the ground fault current, which will be if our ground zero sequence current will be in these areas near to our rail axis, a little beyond, a little lagging, little leading. Then on that time we use the method of measuring G0 and the phi correction. We tilt our symmetrical axis by which was initially into horizontal, and now we tilt it by plus 45 degrees and we find the G0 according to the formula that we will discuss later on. And if our zero sequence current be almost in this area much more, it means that the system, which is isolated system, and the capacitive current is very high, it means our system is isolated and underground cables. On that time, this zero sequence current will be in this area. Almost our zero sequence current will be in these areas. It means it will be more capacitive, and the capacitive current of the system is decisive for the fault. It means the current which is in this axis of imaginary axis into reverse part, this current is more decisive for the fault. On that time, instead of tilting this angle, instead of tilting this angle to 90 degree, because our symmetrical axis should be, the decisive part of the current should be perpendicular to the symmetrical axis. Now instead of tilting symmetrical axis to plus 90 degree, what we do instead of G0, we should select that the finding the B0 instead of G0, because this is our B0 axis and this part of decisive current is on the B axis, on the negative side, of course, on the negative side of B0. On that time the angle between the V0, which was initially in this axis V0, and the I0 is in this area. The angle was here was alpha, which we discussed before. Now we want this value. We want this value. Here we are discussing about Y0, of course, instead of I0, and this value is about the sine. So instead of selecting, before we were selecting the sine instead of cosine, now we are, instead of B0, we are using the method of measuring as a B0 instead of G0. That is this guy, which we select our axis here in this direction. This is our symmetrical axis right now, and this is our y0, the component which is perpendicular to this symmetrical axis. This is y0 directional. This is for the fault current. This is for the fault determination direction. And here, this is that alpha, that angle which we discussed. And this value is this y0 directional. This is about the sine, and we, instead of G0, we use now B0 for measuring method. And this is our symmetrical axis initially. We have not tilted, so this is phi correction we add as a 0, 0. And this alpha 1 and alpha 2 is reduction direction area angles, which initially it is 2 degrees, but if we want this area to be more less sensitive, and it should be more close, in a small area our pickup should occur. It should not pick up in these areas, so we can increase this alpha 1 and alpha 2. Now the point is that beyond which values of these thresholds, beyond which values of B0, our system should pick up. And what's the amount of this threshold value for this B0? That is that the B0 value in the isolated system should be greater or equal to I0 minimum divided by V0 threshold. Then this V0 threshold is 0.02 into root 3 into V rated. That V rated is around 100 or 110. According to your VTs, you can see on the VTs installed in your system that how much is the rated secondary voltage for the VTs. And this I0 minimum, this we already discussed, that in the system, if you have the covalence transformer, this is around the 5 to 10 milliamperes, and if you have Holmgren current transformers installed, Holmgren configuration, then it is around 50 to 100 milliamperes. How you should find? In normal condition, there is no fault, so you can measure this amount of current normally, and you expect that this is the minimum amount of the current that during normal condition is flowing on the secondary side of the neutral CT. Then that value we put on I0 minimum and divide by V0 threshold. This is the V0 threshold, which is 0.02 into root 3 into VR rated. And if you have not subscribed our channel, please subscribe our channel and share the video with your friends. Help us provide you more free training videos.